Hello learners, and welcome to a video tutorial on how to go about calculating current and voltage across resistors in a slightly more complex circuit than you might be used to. So here I have 5 resistors. R1, R2, and R5 are connected in series, and they are connected in series with these 2 resistors that are connected in parallel with each other. Okay, and I'm going to show you how to go about calculating the voltage across each resistor, the current through each resistor, and then also this initial current I0. Now, to do this, what I'm going to do is I'm going to employ a verb table. Now, here are your values for R1, R2, R3, R4, and R5, and then our voltage is, let's not make it a 2-volt battery, let's actually make it a 6-volt battery. So take a second, pause the video on 3, 1, 2, 3, and hopefully you wrote those down. So let's go about making our verb table. Now by verb table, here's what I mean. I mean voltage, current, resistance, and power. And our rows are going to be the individual resistors, and then I'm going to have this total down here at the bottom. Now, by total, I mean the entire circuit. So for total, this would be R equivalent for the entire circuit. This would be the total voltage for the battery. Now, this is something that we already know. I know that the total voltage is going to just be the voltage of the battery, which is 6 volts. Now, I know each resistance value, so I can go ahead and put that in there. So R1 is going to be 1 ohm, R2 is 2 ohms, R3 is 1 ohm, R4 is 2 ohm, and then R5 is 2 ohm. Now, to go about this, we're going to be employing Ohm's law, V equals IR, and then power is PIV, current times voltage. So if I know 2 things in a single row, I can figure out everything else in that single row. So I know voltage. If I knew the total resistance, I could figure out the current coming out of the battery. Now, what I'm going to do next is figure out the total resistance in the circuit. To do that, I'm going to take a look back at my circuit, and I'm going to kind of simplify out. These 2 resistors are in parallel. Parallel resistors, the R equivalent is the reciprocal sum. So I'm going to go 1 over REQ1 equals 1 over, in this case, R3 plus 1 over R4. Now this is REQ1 for representing the first equivalent resistance that I calculate. The more complicated a circuit gets, the more confusing it could become, which means the better nomenclature you need. So for the total circuit, I just call that REQ. For leading up to that, it's REQ1. If I had to figure out another equivalent resistance, that would be REQ2, so on and so forth. So in this case, we got 1 over REQ1 being equal to, well, R3 is just 1, so 1 over 1, plus R4, which is 1 over 2. That gives me 1 and 1/2, or 3/2, but it's the reciprocal sum. So the equivalent resistance for these 2 is just 2/3 an ohm. So what I did is I made this resistor as if it were a single resistor. And so I can kind of represent that by like a little dashed resistor here, and that is REQ1. And REQ1 is 2/3. Well, now all of my resistors are in series with each other. So series resistors, it is just a sum. So now I can figure out the total resistance of my circuit. It is just R1 plus R2 plus REQ1 plus R5. Okay, now that would give me 1 plus 2 plus 2 plus 2/3, which would be 5 2/3, or 17/3 ohms. Now that's total resistance, so I can go ahead and put that in my table. And look, I have two columns in a single row. I can do V equals IR, and I could solve for the current. Now, this total current, remember this is for the entire circuit, this bottom row. That is really like I0, the initial current drawn from the battery. Now, if I go V equals IR, well, that means that I would need to solve for I by dividing V by R. So you do that and you get a value that you could put right here. Now, when you know I0 is coming right off the battery, and there's nowhere for it to go but into R1 and then into R2. So by the junction rule, I now know the current through R1 and I know the current through R2. Now that current goes in right here and it splits. How does it split? Well, I don't know. I don't know how much current goes through R3 and I don't know how much current goes through R4. But I know how much current goes out of that junction. The same that flowed into it, I0, which means I now know the current through R5. It's I0. So that means that R1, R2, and R5 now have the same current. And I can use that to figure out the voltage across each of those. Now, if I do that, I would be solving for V5, V2, and V1. I would still need R3 and R4 because I have two unknowns here. There's a couple ways I can do that. I would utilize the loop rule. I would say, okay, pick a point and start on your circuit and go around that circuit. So I encounter the negative terminal of my battery. So I would write down the negative VB. Then keep going. Here I hit the positive side of my resistor. So I would write down plus, well, VR1. Keep going. Plus VR2. Now you're here. You have a choice. Do you go up or do you go down? If you go up, you would hit VR3. And then you have to come out. You can't backtrack and go over the loop again. When you're doing the loop rule, it's for a single loop. So I come here, I have plus VR5, and then I end up back where I start. When you get back to where you start, it equals 0. We would be able to calculate VR1, VR2, VR5. The only unknown there is VR2. So you can use that to calculate, excuse me, VR3 right there. You could use that to calculate the current through that one. Once you know the current through this resistor, you could, by the junction rule, figure out the current through this resistor. Or you could do the loop rule again, but instead of going up, you go down. You're going to find that these resistors will have the same voltage because they are wired in parallel. So, finish your table.